And finally, part 5 of chapter B. So what about this one? This time we are adding two fractions, so we must have common denominators. We need to completely factor this first. This one will factor into x minus 1 and x minus 3. What about the other one? This one will factor into x3, x4, but since this is plus, the 4 needs to be plus. Let's double check. X squared, 4x minus 3x is 1x, and negative 3 times 4 is negative 12. So it does work. So we have x plus 5 all over x minus 1, x minus 3, plus x minus 1 all over x minus 3, x plus 4. So what is your common denominator going to be? Your common denominator is one of each of these. So we're going to need an x minus 1, an x minus 3. We already have an x minus 3, so we need an x plus 4. So what do I multiply by this denominator to get this denominator? We need an x plus 4. Remember, whatever you do to the denominator, you have to do to the numerator. So we bring down x plus 5, x plus 4. This is plus, so we bring down the plus. Now what do we multiply by this denominator to get this denominator? We just need an x minus 1. So we multiply that here. Okay. Now we're going to have to simplify that numerator. X plus 5 times x plus 4 is x squared plus 4x plus 5x plus 20, or x squared plus 9x plus 20. And we're adding this to this. X minus 1 times x minus 1. So that will be x squared minus x plus 1, or x squared minus 2x plus 1. And it's all over that denominator. Now I'm running out of room, so I'm not going to write this. Well, I'll go ahead. So let's carry this forward to the next page. So I think you remember that being a plus. Alright, we need to combine like terms in the numerator. So we have 2x squared. 9x minus 2x is 7x. 20 plus 1 is 21. That's all over x minus 1, x minus 3, and x plus 4. Now we need to see if this numerator will factor some more. Remember, you do the AC method, so 2 times 21 is 42. You need to list the factors of 42. So 1 and 42, 2 and 21, 3 and something, 14, 4 won't work, 5 won't work, 6 and 7. So it's all of these, or you could have the negatives of all of these. But since this 7 is positive, we know we need the positives. So do any of these add up to give you 7? They do not. So this is as far as this will go. If the numerator would have factored some more, you would factor it and then see if you could reduce the fraction further. So how is subtraction any different? Well, remember, go ahead and see if you can factor everything. So we're going to have a minus 1, this is difference of squares, so we have 2a plus 3 and 2a minus 3. minus a minus 2 all over, now I want you to notice this one, 3 minus 2a. This is written backwards if you think about it in terms of a polynomial. You want your variable listed first, so that would be negative 2a plus 3, right? Normally we don't really like our leading coefficient to be negative, so let's factor out that negative. If we do, we get 2a minus 3, right? So let's put that here, negative 1 times 2a minus 3. Well, I do have another question for you. If you have 1 over negative 1, is that equal to negative 1? Yeah. And if you have negative 1 over 1, is that also equal to negative 1? Sure. So why don't I take this negative 1 and put it in the numerator? Okay, so what happens if you have a negative of a negative? It turns out to be a positive. So that might actually help us out in the long run. What's going to be our common denominator? We need a 2a plus 3 and a 2a minus 3. We already have a 2a minus 3, so we don't need that one again. What do you multiply by this denominator to get this one? Just a 1. So this turns into just a minus 1. Plus, well, what do you multiply by this one to get this denominator? Here you're going to need to multiply this by the 2a plus 3. So that's what we multiply by in the numerator. So we put that here. A minus 2 times 2a plus 3. So let's carry this over to the next page. We need to multiply this out. We're going to have a minus 1. Here we have a minus 2 times 2a plus 3. So we get 2a squared plus 3a minus 4a minus 6. So 2a squared minus a minus 6. All over this common denominator. Combine like terms again. Here we have a and minus a, that's 0. Then we have negative 1 and positive 6. So 2a squared plus 5. Oh, that's a negative 6, right? Because of this. I don't know why those negatives keep doing that. So this is going to be minus 7 all over 2a plus 3 and 2a minus 3. This will not factor anymore, so it is completely simplified. What if you have a complex fraction? For a complex fraction, the very first thing you want to do is find the common denominator of all of the tiny fractions. So what do 2a squared b and 1 and 4ab cubed and 3b all have in common? Well, just looking at the 2, the 4, and the 3, you know 12 is the common denominator. Here we have a squared and a, so we definitely need some a's, but we need the most of each of the ones we see. So we see 2 a's here, we need that one. Here we have b, a b cubed, and a b. Well, the most b's we see would be 3. So your common denominator is 12a squared b cubed. You want to multiply this fraction by 1 in the form of that common denominator. So 12a squared b cubed. What you're going to do is distribute that across, just like that. Okay? I'll write everything out so you can see what's going on. We have 12a squared b cubed over 2a squared b. minus 2 times 12 would be 24, and this a times this a squared would be a cubed, and we still have the b cubed, all over 1 in the denominator. It's 1 times all of that, and then 4ab cubed in the denominator, and then we multiply this one, so we have plus 12a squared b cubed all over 3b. Now, if you'll notice, each of those little fractions is going to reduce, and that's what we want to happen. So let's take this up here and start reducing stuff. We have 12 over 2, that's going to be 6. We have a squared over a squared, and then we have b cubed over b. That means this b will go into these b's, leaving 2 of them. So we have b squared minus all of this over 1 is just 24, a cubed, b cubed. All over this one, 4 will go into 12 3 times. This a will go into these, leaving 1a, and these b's completely reduce. 3 will go into 12 4 times. A squared has nothing to reduce with it, and this b will go into these, leaving 2 b's. Now see if this will factor any further. In the numerator, we could factor out a 6 and a b squared. If we do, we're left with 1 minus 4a cubed. In the denominator, you could factor out an a, and you're left with 3 plus 4ab squared. Now, if you notice, nothing will reduce at this point. So you could have actually left it this way. If you want to make sure nothing reduces and you've already done the work, you might as well leave it this way. These are the problems that you'll need to work for Chapter P. You can print this out from your track site, and you can also print out the problems from tracks, or you can print them out from your ebook in My Math Lab.